Okay, here's a question on limits from AP Calculus. So we have limit as x approaches 2 with a little minus on top. So one second, let me lock this first. Okay, so we have limit as x approaches 2 minus p of x. The graph of p of x is given here. But what does this even mean? What this essentially means is, what is the y value of p of x approaching as x approaches 2 from the left side? That's what the minus means. Okay?
Infinity then.
Yeah, because this is x equals, well, let me change colors. This is x equals 2. And if I approach x equals 2 from the left side, then on the graph, I am approaching infinity because the y value
Yeah.
is going to infinity. It is suggested to not say equals infinity because infinity is not a number. You cannot equal infinity. So we instead use a line
Mhm.
and say is going to
Approaches.
infinity. Okay? Or yeah,
Yeah.
approaches infinity. Similarly, the limit as x approaches 3 from the right side of p of x. So what
Mhm.
is that going to be? So limit as x approaches
As
3 positive.
3 positive, then that would be -1.
Negative 1. Because this is where 3 is. And if I'm approaching from the positive side, then I would be approaching this y value, which is negative 1. Okay. Similarly,
Yeah.
what is the limit as x approaches 3 in general? So what does this mean? This means you have to find out the both-sided limits, both one-sided limits. So
Mhm.
you want to check what the right side limit as x equals 3 is, and you want to check what the left side limit on at 3 is. If both of them are the same thing, okay, then we
Yeah.
say that the general limit exists and it's equal to whatever both of them are equal to. Okay, but
Mhm.
this is, by the way, very important. This is how you check the existence of a limit. We will transfer this skill for the longer questions in a bit. Existence of limit, the only way to check whether whether a limit exists. So if you want to check whether limit as x approaches a in some kind of function exists, you have to check both one-sided limits at that point.
Mhm.
So the right side, the left side, and then you need to check if they're equal. If they are equal, then they also equal the actual limit. If they're not equal, then the limit does not exist at all. If they're not equal, then this does not exist. Okay? Is this clear?
Yeah.
Perfect. So, what do you think so we already found the right side limit. It's -1. What about the left side limit? If I approach x equals 3 from the left side, what happens?
Um, that will also be -1.
Exactly. If the right side limit and the left side limit is both -1, then this whole thing equals -1. Okay, that's the
Yeah.
idea. Similarly, can you tell me what the left hand side limit at x equals 5 is? So 5 is right there. What's the left hand side limit?
5 left-hand side would be at 1.
1. Because if you approach from the left side, then you're approaching this hole. Even though the graph doesn't exist there because it's a hole, it doesn't matter because we're approaching that y value. It doesn't matter that we never get to it because there's a hole there. Regardless, from the left hand side, it's 1. What about from the right side?
It would be -1.
-1, because if we approach from the right side, we get to -1. We approach -1, which means that
Yeah.
if I now ask you, what is the limit as x approaches 5, what will you say?
1, -1.
If the left hand
يعني
side exactly does not exist because the one-sided limits don't match. Okay?
yeah.
So how can you generally say that it's approaching one and not the other? Because from the left
Mhm.
side you're approaching something else, right side you're approaching something else. So you're not allowed to say that you're approaching uh, either of them when you're approaching x equals 5. Finally, what is the limit as x approaches -1?
Which is -1. It would be 0.
Yeah. Because when x approaches -1 from the left side or from the right side, it approaches the same y value. Now, this is, by the way, a very important point. The function itself does not even exist at x equals -1, but that does not matter because we're talking about approaches. We're not talking about standing at this point. We can't
Mhm.
stand at this point because there is no point there. There's a hole. We'll fall through it. The function doesn't
Yeah,
exist at this point. But that doesn't matter to us. Limits are more about approaches than they are about actual values of the function. Okay?
yeah.
So that's the idea here. Now let's look at how to find limits of functions analytically, basically using algebra to calculate limits. Okay?
Yeah.
So let's look at the first one. So limit as x approaches 4 in this very big function. Now, the method to solving most limit questions is gonna rotate between um, three main techniques. Okay? When
Yeah.
you see a function that is purely algebraic, like this, I mean, what I mean is there's no roots in them. I shouldn't say purely algebraic because this is also purely algebraic. When you see a polynomial, basically, okay, so when there's no roots involved and there is no piecewise function involved and there is no absolute involved, it's just a pure polynomial with a bunch of, polynomials, basically. That's all I can say. What are you
Yeah.
supposed to do? Factorize. In
Mm-hmm.
general, the first step, it's almost a preliminary step. It's always going to be used. Preliminary step to every question will be to try to just plug in the x value directly and see what happens. Okay? You should do this every single time. Never ever skip it. Okay? Because
Yeah.
this helps you diagnose the problem. Because when you do this, you'll realize what the issue is. In this case, if I plug in 4, I will get 2 times 4 cube at the top, minus 7 times 4 square, minus 4 times 4 at the top, so 0 at the
Mm-hmm.
top, and I will also get 0 at the bottom. Okay?
Yeah.
This is a problem. Whenever you get 0 over 0, this means that the real answer is being hidden from us. The real answer is not 0 over 0 because 0 over 0 is one of the forms that we call indeterminate. It's an annoying thing that hides the actual answer from you. Okay? So there are a bunch of indeterminate forms. Do you remember them?
No.
Okay. So let me try to find a list of them. I don't think they have shown them in the book, but there's a few, and all of them are just as illogical as 0 over 0. For example, infinity
Yeah.
over infinity, I believe, is also an indeterminate form.
Okay.
Anyways, the reason we did this preliminary step is because now we know that we have an indeterminate form. If we had 4 over 0, the answer would simply be infinity. Okay?
Yeah.
However, 0 over 0 is not allowed because 0 over 0 doesn't mean anything. So now the first step is factorization. Factorize everything as much as possible. Okay? So
Yeah.
what's the first step to factorization that you can take in this case?
Uh, the X.
The x at the top, right?
Yes.
So what's left inside if I factor that out?
2x cubed
No, no,
minus,
2x
sorry,
squared.
2x squared minus 7x minus 4.
Good. And at the bottom, I have an x minus 4. Now, we need to factorize this too because it's a quadratic and we know how to factorize quadratics.
Yeah.
So,
The product sum.
yeah, exactly. So we need two numbers. So let's think about it like this. So let's use the product sum rule as you said. We need two numbers that add up to what and multiply to what?
Add up to 4 and multiply to 7.
Add up to no.
Oh, sorry,
Add
sorry. Add up to 7, multiply to 4.
so add up to -7 first of all.
Yeah.
Remember the signs, they're important. And not
Yeah.
multiply to -4. Multiply to -4 times 2.
Oh, times 2,
Don't forget
yes.
that. So which two numbers would multiply to -8 and add to -7?
Um, negative 8 times 1.
Exactly. -8 and +1. So let's put the
Mm-hmm.
-8 here and the +1x here. Don't forget the x, by the way, because they have to add up to -7x technically. Okay,
Yeah.
right? So now factorize the first two numbers by taking a 2x out, which gives you x minus 4 inside. Factorize the second 2 by taking a 1 out, which gives you again an x minus 4 inside, which leaves you with 2x plus 1 and x minus 4,
Mm-hmm.
right? Now, which means that I can rewrite this again as this,
Yeah.
and this tells you why you were getting 0 over 0, because you had a 0 thing here and a 0 thing here. If you plug in 4, this guy becomes 0 and this guy becomes 0. They were the ones that were secretly causing the 0 over 0, okay? But they can be cancelled out, okay? You see?
Yes.
So this makes our question into a new question now. We have the limit as x approaches 4, not of all of that, but actually just of this, which
Mm.
is just going to be 4 times 2 times 4 plus 1, which is 36. Because this is 9, 9 times 4 is 36. That's your answer. So you see, preliminary step will tell you what the issue is, and you will learn to spot what the issue is by using the preliminary step slowly as you do more questions. Okay? So now I want you to try to do question 3, okay?
Okay.
So try that on your own and work through it and tell me what you get. We have limit as x approaches 1 in x squared minus 2x minus 5 over x plus 1. I'm going to quickly factorize 1 second. Oh wow. Okay, this is interesting. Hmm. Okay, so what did you do to get this, by the way?
I couldn't factor it more,
But did
honestly,
you did
so
you did you do the preliminary step? I expect no, right?
oh no.
But watch this. 1 minus 2 minus 5, that is negative 6 if I remember. Yeah, so the answer is going to be negative 3. So it was as easy as just plugging in the limit directly because we were not going to
Yeah.
get an indeterminate form anyway.
Yeah, that's what I did.
Yeah, okay, so that is the preliminary step. The preliminary step is directly plugging in the limit and seeing what happens.
Okay,
Yeah.
okay, okay.
So the
Because I thought
like
you'd have to expect a okay, okay, never mind, never mind.
and see what happens. So don't forget to do, I mean, that's what you did, but don't forget
Yeah.
to do this. This is like,
Yeah.
because sometimes, it sounds like this might never ever show up, but that's the thing. Hits you when you least
Mhm.
expect it. I've seen this in my calculus exams in university even. Like a 2-pointer. I'm like, why is this limit question a 2-point question? And I realize why in a bit, once you look at it
Yeah.
a bit. A telltale sign is that if the x value is not causing the denominator at least to become 0, then you might just be in for a nice question because you might just be able to plug it in and get the answer. So I want you to look at question 2 now because that is going to show you how all it's this method of just simply factorizing simple like directly does not apply all the time, or at
Yeah.
least simple factorization doesn't work all the time. So but ultimately the idea is always factorization. Let me show you what I mean.
Mhm.
So first of all, without actually writing it down, we can already see that if I plug in 9 at the top, I have root of 9 3, 3 minus 3 is 0, and 9 minus 9 is also 0. So this will equal 0 over 0, which means that the actual answer is something real that I need to figure out. Okay, perfect. So let's begin. Uh, Now, what do we do here? The thing is, it's not very easy to see all the time how you can factor this, but this specific technique is weirdly common in calculus. Okay, we are going to
Yeah.
realize that 3 is the square of 9 and root x is the square of x, right? You
Yeah.
see that? Okay. So again, if you square root x, you will get x. If you square 3, you will get 9, which means that we might be able to do something with this guy. You see? So
Mhm.
let's figure this out. What I'll realize is that if I rewrite the bottom of this equation as 3, so I'm going to rewrite the equation, right? Root x minus 3 over 3 squared minus root x squared. Okay.
Mhm.
Why did I do this? Because now I have a square minus b square, which I can convert to a plus b, a minus b. So a plus b, a minus b, right? You see what I did there? Because
Yeah.
I have a square and b square, so I convert to a plus b, a minus b. Okay. Now, the problem is I can't cancel this out with anything. I don't see the same exact thing at the bottom, do I? So what solution do you suggest here? Because I need to cancel this, right?
Yeah.
How do I cancel it?
Can you try plugging the limit in? Just from
I mean,
here?
no, if I plug, I mean, I haven't changed anything. I've just literally
Yeah.
opened it up. So if I plug in the values, I will still get 0 here and a 0 here. Because see,
Hmm.
square root of 9 is still 3, square root of 9 is still 3. You're going to get
Yeah,
0
yeah.
over 0. So what we do is we look at this guy and then we look at this guy. Do you see the relationship?
Yeah, it's like inversed kind of.
Not inverse, negated basically,
Yeah,
right?
yeah.
So if I rewrite this by taking a negative out of this, it basically becomes the same as that,
Hmm.
right? Which leaves you with this. Okay?
Yeah.
And now you see the same term at the top and the bottom. So as I said, it's not always very obvious on how you're supposed to factorize. Sometimes you
Yeah.
even have to force a factorization to happen in order to be able to cancel out the thing that's causing you the trouble. Okay?
Mhm.
So we canceled out the things that become zero if I plug in the limit directly, which leaves you with this. Okay?
Mhm.
And now I can finally rewrite my limit, and now I can plug in a 9 directly, which leaves you with this minus 1 over 3 plus 3, which is minus 1 over 6. Okay, so the main trick was right here. Okay,
Mhm.
I mean, there was an additional step that I had to do, which was this thing to make the cancellation happen. However, this was a very important thing that will happen very often. Okay, so you will see this kind of situation happening in calculus very often, so make sure you understand this. You have to force a difference of squares to happen. Let me give you a sample question, I guess, for a similar situation. Okay, I need to build it, so give me a second. Okay, so what did you get, or actually
So,
how did you get it is a better question.
so first I tried direct substitution and then I got 0 over 0.
Yeah, good.
But I was able to simplify the numerator and I
Factorize
got
the simple numerator.
4 outside open brackets 4 minus x.
Okay.
And then uh I was able to simplify the denominator by doing uh 2 outside 2 minus
Root x.
uh, square root of x.
Okay. What did you do after this?
After that, I had to do the
Difference in squares?
thing where I add like the same numerator and denominator. Like
So, like, tell me what you wrote down essentially.
I had 4 into 4 minus x over 2 to 2 minus square root of x times the 2 plus square root of x over 2 plus square root of x.
Okay. So you got 4 minus x, 2 plus root x, and at the bottom, what did you have?
Um, I had 2 uh 2 minus square root x times 2 plus square root x.
Yeah, so did you multiply that out or?
Um, and then, yeah, I got 2 times 4 minus x.
Yeah, because you have a minus b, a plus b, so that's going to be a squared
Yeah,
minus b squared. So we will have 4 minus x, right?
yeah,
So we have 2 plus root of x at the top, which means that we cancel these two out, which leaves us
exactly.
with just this.
And then you
So
can simplify the
yeah,
2.
exactly. So that leaves you with this. And
And
now
then I
we
got 8.
can, yeah, we can now plug in the 4,
Yeah,
which leaves you with 2 times 2 plus root of 4, which is 2 times 4, which is 8, right?